Hello and welcome to the Applied Cyber and AI Risk Assessment for Organizations series. This is part of Inland Cyber Defense Clinic, and this course was presented in summer of 2026. So without further ado, let's get started. We're going to talk about why we focus on cybersecurity, a couple of points, and the first one is the attacks are accelerating in frequency and sophistication. In 2025, there was a report showing that the organization faced an average of 1,900 cybersecurity attacks per week, which is an 18% increase from 24 and 70% increase since 23. And over 2,000 attacks occurs every single day worldwide. The other reason for studying cybersecurity is in 2024, the cybercrime was the world's third largest economy. If measured as a country, cybercrime projected to inflict $9.5 trillion in damage globally, which would be the world's third largest economy after US and China. And another reason was that in 2023, 46% of the nonprofit organizations reported that a cybersecurity incident happened in the organization, and only 26% of them had a formal cybersecurity policy. In terms of the financial compensation, on the right side we have a screenshot of the EC Council showing that the top 10 highest paying cybersecurity roles. These are average for US, I believe, and I've seen people with similar role who get much higher salary base. So this is just an average based on the data that was collected in 24, I believe. Moving on, we're going to talk about the CIA triad. So the first one, the C, stands for the confidentiality. Confidentiality meaning that only authorized users can access and modify data or systems. The I stands for integrity, meaning that data are not being modified or tampered with by unauthorized users or authorized sources. And finally, the A is for availability, which means that data is accessible when needed. Talking more about the CIA triad, a couple of examples about confidentiality. The things that can help with the confidentiality are encryption of data at transit and at rest, having a strict access control, the idea of least privilege comes to mind here, having multi-factor authentication, patching the softwares, and if we have systems or data that are not being used, we have to have a process to securely destroy them. And user training is another important part of the confidentiality. Moving to integrity, we can use a couple of techniques. Input validation. We want to make sure the data that goes to the database or the data that goes to AI system and the data that's coming out of the system being validated and monitored using the hashing algorithm for integrity is important. Having a digital signature is important. Using the access control here, the idea for the the idea of least privilege is important here. So we have the access control in confidentiality. In confidentiality, we're making the main point is the read access. In integrity, the access control is mainly concerned with the write access. And another important tool that we can using is auditing and version control to keep the integrity of data and systems that we have. And finally, the techniques that we can use for availability. We can use some hardware high availability measures like RAID or clustering. We definitely can use the backup system or a disaster recovery plan. And also we can use the virtual private networks to get authenticated user access to data, so it would be available for them. What we want to make sure about the CIA triad, we want to make sure that we have a balance of all three. For example, if we have a super confidential network and the integrity, if it's in the highest possible degree, but if we don't have a way of accessing those data and those systems, that basically defies the purpose. So we have to find a balance to have all of these three work together. Moving on to definition of the assets in AI and in traditional cybersecurity. So we start with the left side, the traditional cybersecurity. So we have on the top, we have the computers and servers, very important assets. And on the right, next to that on the right side, we have the network appliances. And then we have the data and storage media, things like NAS or SAN are they belong here. We have printers and other peripheral hardwares that are connected to the network. Software and licenses are part of the assets. And we have a supporting infrastructure. For example, if you have a cloud portion of our system, that's also part of the assets. And the definition of the asset, I might have forgot, is anything that has a value to the organization. And because of that value, needs to be protected from loss, misuse, or damage, or unauthorized access. On the right side, we have the AI assets. So we start with the data set. So data set is the data that AI systems use to train or validate or run the AI systems. That could be customer data, images, or sensor information. We have the next AI assets is the prompt, which is the instructions that are given to the AI systems. We have the API, excuse me, which is the application programming interface, which are the interfaces that allow applications to use to interact with other AI services. We have the compute portion, which is the GPU or graphics processing units. So those are expensive and critical piece of hardwares that help to basically the AI models run. They run the AI models. And again, important piece of assets, and sometimes they can be pretty expensive. We do have the other assets is the pipeline, which are the automated workflows that the data can move through. So, for example, for collecting the data, for training the models, for testing the models, deployment and monitoring, those are all they could be the part of the automated workflow that they move the data within the AI systems. The next one is the output, which is the responses or prediction that the AI system have. They could expose sensitive information, or they could have harmful content or biased decision. So we have to be aware of that. We're going to talk about some measures to prevent the AI system to come up with these kind of outputs. We have embeddings, which are another part of the AI assets. So embeddings are basically the numerical vector representation of text, images, and other data, and can be used to infer sensitive information or manipulate retrieval systems. So those are important assets in AI as well. And finally, we have the models, which are basically a lot of times they are like proprietary models. What they do is they contain the learned behavior logic that they were trained with those data sets. So those are also important part of the AI assets. Moving on, we're going to talk briefly about a couple of terminology here. So the first one, we have a vulnerability, which means a weakness, error, or bug that can be exploited. So for example, an unpatched software on a server is a vulnerability. Moving on, we have threat, which is an entity, for example, a system or person that has potential to compromise a system's security. So basically any potential danger to our system. An example would be a hacker targeting our network. Then we have the exploit, which is the method that is being used to leverage the vulnerability. For example, a script targeting an unpatched software is exploit. That's the method that is being used to leverage that vulnerability. And we have the attack, which means a malicious action that violates the system's security. For example, when we have a ransomware deployed on a system, that's the actual malicious attack that is compromising and is affecting our system security. Moving on, we have the threat actor taxonomy. Basically, what kind of different people or organizations or countries can be involved in a threat or in an attack. One of the category is nation or states, meaning that when a country or state is behind some kind of attack to get information from a different country. We have other businesses. Basically, corporate espionage is part of this, when different companies try to get competitive advantages sometimes they use this. I mean, the businesses could be a part of the actor here. The other group is the cyber criminals. That's the financially motivated attackers that are seeking profit, and they are trying to exploit different vulnerabilities. We have hacktivists, which are doing malicious activity, or sometimes they do some activity to bring awareness for or promoting for the cause that they are supporting. And the other threat actor group are insiders, which are current or former employees who, for whatever reason, they are misusing the trust that the organization had with them, and are exploiting the vulnerability of their company or of their previous company. Moving on, we're going to talk about the attack surface versus attack vector. So attack surface is the total sum of all possible entry points. It could be digital, physical, and human. And where an unauthorized user could attempt to access or extract data from a system or organization. And that was the NIST SP 800-53 definition. So, for example, if I am if I'm trying to rob a house, I can enter through the door. I can enter through the window. I can get in, for example, through the roof. Or I can have somebody from inside helping me to get into the house. So these are all of the different attack surfaces that a thief can have. The attack vector is a specific path or method or means by which the attacker gain authorized access to a system. So, for example, in the example of robbing a house, if I use the window to get into the house, that window is the attack vector. Or in a real world, if we have, for example, if the attacker uses an open port and the firewall, that would be the attack vector that specific attack is being used by. So we have a couple of other definitions. This one is a definition of the risk. So risk, the NIST definition of risk is a measure of the extent to which an entity is threatened by a potential circumstance or event, and typically a function of 1, the adverse impact that would arise from the circumstance or event occurs, and B, the likelihood of the occurrence. So typically, if we multiply the likelihood by the impact, we get risk. That's the generic definition of the risk. So we have risk assessment that can identify the threat and vulnerabilities and estimate the likelihood and the impact of the harm and prioritize risk to support informed decision making for the organization by their stakeholders. One of the common ways to assess risk is called factor analysis of information system, or FAIR, which is a quantitative risk analysis model that produces a dollar amount estimate of the loss exposure. And yeah, that was a brief definition of risk. Okay, moving to artificial intelligence. We have a couple of definitions. Before we dive to the AI, we just want to make sure we have a common language around what the AI actually is. So at the left side, we have the AI kind of technology stack, how the modern AI systems are constructed, and which on the broadest level we have the artificial intelligence, which is basically systems that can perform tasks requiring human-like intelligence. So things like spam filter or fraud detection monitoring system, or Siri or Alexa or other type of voice assistants belong to this category. So inside the AI, we have the machine learning. Machine learnings are basically the system that can learn patterns from data and improve performance without explicit programming. And some of the examples are, for example, the recommendation engine for Netflix or YouTube, credit risk models, or convolutional neural networks, or CNN, are part of them, are part of the machine learning. Then we have the moving on the next generation of the AI is basically the foundation models or general purpose AI. Those are the large scale models that train on a broad data set that can be adapted to many tasks. So GPT-4, Claude 3 Opus, Gemini 1.5, or Llama 3 by Meta are some of those examples. So then we move to the large language models, which are a specific type of foundation models that are focused on understanding and generating large text and language. So LLM is one of the important type of the foundation models, and many of them are considered the general purpose AI systems because they can perform many general purpose tasks. So here, GPT-4, GPT-4o by OpenAI, Claude 3 Sonnet, and Palm 2 by Google's are examples of large language models. And finally, we have the generative AI, which refers to applications built on top of these models that can generate content like text, images, audio, or codes. So that's basically the definition of the generative AI. Now, on the right side, we have the typology, meaning that the different categories of AI system. So the first one is narrow or weak AI, which means that they are designed for a specific task. Majority of the AI that we're using are narrow, for example, spam filters, AI receptionist, fraud detection systems, or chatbots. Then we have the generative AI, which produce new content, mainly or often they are built on the foundation models. Then we have agentic AI. So those are type of the AI that can plan, act, and make decisions across multi-step workflow autonomously. And finally, we have artificial general intelligence, AGI, which is right now are the hypothetical systems that reason across any domain like human. They're not 100% completed yet, and those are basically the holy grail of the AI systems. Moving on, talking about how artificial intelligence differs, how AI risk differs from traditional risk. So in terms of predictability, traditional cybersecurities are usually well understood, bounded, and relatively stable over time. Compared to the AI risks, which are very emergent, unpredictable, and opaque. We cannot understand why sometimes a certain decision or a certain action are happening by the AI. And they are sometimes unpredictable even to its creators. About the explainability. So in traditional cybersecurity, we usually have we can usually trace back to rules, logic, and data and decide why this decision was made. But in the AI risk assessment, in the AI risk models, we are dealing with very complex models, and they may not be explainable, and we might not be able to explain why a certain output or decision was made. In terms of bias and fairness, usually in the traditional cybersecurity, bias is known, bounded concern that can be audited manually. In the AI, we can have bias because of the training data, and that could harm a lot of people or a lot of decisions automatically and silently. Moving on, we have on the threat surface, so traditional risk having the phishing, malware, inside threats, unpatched vulnerabilities. Those are the common threat surfaces that we have in traditional cybersecurity. In AI, we have things like prompt injection, data poisoning, model evasion, adversarial input, and deep fakes, which are type of the attacks, which we're going to talk about. In terms of the governance framework, traditional cybersecurity, we have NIST CSF, ISO 27001, SOC 2, and NIST SP 800-53. In terms of the AI, the frameworks that we have NIST AI, RMF, we have MITRE Atlas, we have OWASP Top 10 for LLM and for agentic, and we have Google Safe as some of the examples for governance framework in AI. About the speed of change, it's important to notice that we have in traditional cybersecurity, the risk evolves pretty slowly, usually within months, years, sometimes weeks. So frameworks usually can keep pace, but in AI risk, the speed of change is usually weeks, days, hours, or minutes, and they can update silently and continuously in the background. Moving on to so just to review this predictability. Again, traditional cybersecurity, they are usually predictable. With the AI, they are opaque and emergent. Explainability in cybersecurity, traditional cybersecurity, we have a traceable decision. We can trace the decisions, why did those decisions was made. In AI, we have kind of like a black box situation, which we cannot understand why certain decisions were made. Bias and fairness in cybersecurity, traditional cybersecurity, we usually have a localized impact, but compared to the AI risk, in AI risk we have scale which are much larger than the traditional cybersecurity, and they can scale silently. In terms of threat surface, traditional cybersecurity, they usually have known threat. In AI, we have new attack vectors appearing every hour. In terms of governance, we usually have established framework for traditional cybersecurity. In terms of AI, we have some frameworks that keep evolving as the technology moves forward. Speed of change generally in traditional cybersecurity is slow, but in AI risk, we have pretty rapid changes compared to traditional cybersecurity. So basically, AI risk is, we have the opacity factor, we have the scale factor, and we have the speed factor, which are differentiated the AI risk from traditional cybersecurity. We're going to talk briefly about AI risk landscape, specifically from the MIT AI risk taxonomy. So there are 7 domains that the MIT AI risk taxonomy covers. The first one is discrimination and toxicity, which means that the AI system can produce biased, harmful, or degrading output, often reflecting biases in training data. The other domain is privacy and security, which means the AI tool can expose sensitive data through vulnerabilities in how that they process, store, or transmit information. We have misinformation, which means that the AI can generate or amplify false information at the scale. For example, deepfakes, fabricated voices, or synthetic content are some of the examples. The other domain is malicious actors. So attacker can weaponize the AI to automate phishing, conduct espionage, or do cyber attacks faster and at a greater scale that was done by traditional cybersecurity, or traditional cybersecurity attacks. The other domain is the human-computer interaction, which talks about the over-reliance of AI. Over-reliance on AI for decisions making, and emotional support could lead to poor outcomes. For example, bad advice and psychological dependencies are some of those examples. We have the socioeconomic and environmental domain, which talks about the AI adoption can displace workers, increase the inequality and consume significant energy and water resources. For example, we know that if there is a data center is being built in a location, the price of electricity and water is going to increase in that location. So that's the socioeconomic and environmental domain of AI risk. And finally, we have the AI systems safety and failures. So AI system can fail silently or produce incorrect output with high confidence. So we all know that we cannot always rely on the AI every time with high confidence, basically. We have to check the output. Sometimes we need for some important decisions, we have to have a human taking the final decisions to make sure that not everything being controlled by AI. That's it, basically. If you have any questions or comments, please post it below. And I hope this has been informative for you. And thank you for listening and watching to this video.